Right, good day and welcome. I'm Mr. Simons. This lesson we'll be drawing hyperbola using table method, right? So, table method, to give you equation, plot the graph y equal to 1 over x using the table method. Now, if x equal to 0, equation becomes undefined. So I hope you remember from grade 9 work, 1 divided by 0 gives me undefined. Right, in the table I've selected minus 3, minus 2, minus 1, 1, 2, 3. So 1 divided by 1 gives me 1. 1 divided by 2, a half. 1 divided by 3, a third. 1 divided by negative 1 gives me negative 1. 1 divided by negative 2, negative a half. 1 divided by negative 3 gives me negative 1 over 3. Now generally, equation for hyperbola, x will always be a denominator, right? So if we plot this now, they have 1 and 1, I have 2 and a half, and they have 3 and a third. You should see the graph curves there in the first quadrant, but it's not making contact with the y-axis or the x-axis. This side here, minus 1 and minus 1, minus 2 and negative half, and 3 and negative a third, and there it curves. So hyperbola, basically there's your shape of how hyperbola looks. That's in second or first and third quadrant, right? That's because the one on top is positive. Right, let's go further. So note, we have what we call asymptotes. Remember I said the graph doesn't touch the y and x axis. So note, this graph is not making contact with the x or y axis, and this is due to the following. So if I say x-intercept, meaning where it's going to make contact with the x-axis, I have to make y equal to 0. So if y there is 0 equal 1 over x, x times 0 stays 0, and 0 cannot equal 1. Therefore, y equal to 0, which is the x-axis, on that line y equal to 0, the graph will not make contact with it. Say y-intercept, meaning where does it touch the y-axis? I'm going to say x equal to 0, y equal 1 over 0, so y equal undefined. So therefore it cannot make contact with the y-axis as well. Right, now these two lines are called my asymptotes. The x-axis as a horizontal asymptote and my y-axis as a vertical asymptote. Right, then by now domain, all the permissible values of x. So for the domain, x element of real numbers, but x not equal to 0. So as that graph continues, it will make contact with all my x values on both sides, but it's not going to touch where x equal to 0, which is the y-axis. For my range, my y values, the element of real numbers, is going to go all the way up, touch all the y values, go all the way down, but y not equal to 0. Can also write it as y is the element, meaning going from negative infinity to positive infinity, or y element going from negative infinity to positive infinity. Again, x not equal to 0, y not equal to 0, and there we have your hyperbola. Right, draw another. Right, now again, table method. Plot the graph of y equal to 6 over x plus 3. Again, x is a denominator, so therefore I know I'm drawing a hyperbola. Right, again, if x equals 0, 6 divided by 0 is undefined, so there is 0 undefined. Now we choose the value 1, 2, 3, and minus 3, minus 2, minus 1. 6 divided by 1, 6, plus 3 gives me 9. 6 divided by 2 gives me 3 plus 3, which is 6. 6 divided by 3 is 2 plus 3, which is 5. 6 divided by minus 1 gives me minus 6 plus 3, which equals negative 3. 6 divided by my negative 2 there gives me negative 3 plus 3, which is 0. And there's 6 divided by minus 3 gives me minus 2 plus 3 gives me 1. Right, and if I plot it, there's my point, 1 and 9. Right, 2 and 6, and 3 and 5. If I come further, minus 1 and 3, minus 2 and 0, The I didn't still put in minus 3 and 1. Right, take note here, y equal to 3 as an asymptote. So the graph will not make contact with this red line from bottom and top. At the same time, it's not making contact with the y-axis. So I'll explain again how I get the asymptotes in the next slide. So for asymptotes, y equals 6 over x plus 3. So first, if y equals 3, place in the place of y3. If I bring 3 over, 3 minus 3 is 0. X times 0 gives me 0, and therefore 0 cannot equal 6. So I have a horizontal asymptote at y equal 3. Remember, they always form a horizontal asymptote y. If I look at the vertical asymptote, if I make x equal to 0, y equals 6 divided by 0 plus 3. 6 divided by 0 undefined, therefore the whole equation becomes undefined. And as you can see, vex, vertical asymptote, always with x equal to 0. For domain and range, it will always be for hyperbola, x element of real numbers, for range, y element of real numbers. But x not equal to 0 and y not equal to 3. So hope you enjoyed the lesson. Please like, share and subscribe.